Under 6.5, we are told that we can express the velocity of a particle as a vector. And down there, we are also told that the velocity of a particle is a vector in the direction of motion, and its magnitude is the speed of the particle. The velocity is usually denoted by v. So that is our velocity. And we are also told that if a particle is moving with constant velocity, meters per second, then after time t seconds, it will have moved vt meters. Of course, we know very well from the earlier lessons and earlier classes, we have always learned that the speed of any particle is given by distance over time taken. So if you want to calculate the distance covered, is always given by speed times time. And that is just what we are going to use here. The displacement is parallel to the velocity, and the magnitude of the displacement is the distance from the starting point. If we know that the distance covered, or we've been told that the distance covered is given by Vt, this is the same as St. It's only that velocity is actually speed in a specific direction. So let us look at example 11 and use this information there. We are told that a particle is moving with constant velocity velocity is 3I plus j, or meters per second. Find A, the speed of the particle. The speed of the particle, speed is the magnitude of the velocity, the speed. So the speed is the magnitude of the velocity, which is the root of 3 squared plus 1 squared, which is the root of 10, which is equals to 3.16 meters per second. That is the speed of that particular particle. Remember, speed is just speed, but velocity is speed in a specific direction. That is why velocity is a vector quantity and speed is a scalar quantity, because it lacks direction. Part B of the question is telling us find the distance moved every 4 seconds. Find the distance moved every 4 seconds. There are two ways to approach this question, because we can first of all calculate the displacement. The displacement is velocity times time, and velocity is 3I plus j multiplied by time, which is 4, giving us the total displacement as 12I plus 4j. After we have acquired that, therefore, the distance moved, this is the displacement. Now we need to get the distance moved, which is going to be given by the modulus of the displacement, because we have this as displacement. Now we need to get the distance covered. We're going to have the root of 12 squared plus 4 squared, which is the root of 144 plus 16, which is the root of 160, giving us something to do with 12.64 meters per second. Of course, it's not per second, it's just meters, because we are talking about the distance covered. 12.64 meters. You can either calculate it this way, either that way, or you can first of all get the speed, which is meters per second, 3.16 times time, which is elaborated by t. And of course, using this knowledge, this is speed times time gives us the distance. We can always talk about 3.16 times 4, which is 12.64 meters. Either way, then you'll be there with your distance. All right.